I should apologize, I think, for not using the PDF Association slide template. So probably should apologize to my employer, you know, the enabler of creative professionals for black and white slides, but, and no pictures, so hang in. So this is kind of what I want to cover, an overview, and then a really kind of more of a dive into some of the areas that we're covering with the working group looking at forms. So the goals here, you know, we defined PDF forms a long time ago. I don't know exactly how long it's been since we actually did anything interesting with them. I think it's about 18 to 20 years, right, since we've actually enhanced the spec. And in that time, you know, things like HTML5 have happened. So the world has moved on, and it's really time for us to catch up. So with that in mind, a working group was formed with kind of three initial goals, right, to make forms that will work in responsive mode, to improve our accessibility experience, and to deal with JavaScript. So we've had a working group that's been going, it's almost 2 years now, right? And we've made a lot of progress. We kind of straw man proposals available in all areas, and now we're kind of doing a second pass through it, learning from a reference implementation, tweaking the spec, and starting to write the formal docs. It's an ambitious effort. It covers a lot of area, but be assured it's an incremental approach, so we are going to continue to build on the fields array that you all know and love today. So the enhancements will be based on new dictionaries, new properties. So if you know, the intent is that if a legacy viewer comes across a forms.next file, it should at least, you know, sort of limp along. It won't be by any stretch the real experience, but at least you'll see something. So I have to move a little bit quickly because I think I'm realizing I've got more content than is needed. We'll get into each of these areas as we discuss them. So starting with responsive mode and accessibility, and I lump these together because, of course, they're both rooted in HTML best practices, and they both rely on a well-formed structure tree. So talk about accessibility first. There's two main areas of deficiency in PDF forms today that we wanted to look at: field labeling and field grouping. Again, being informed by what happens in HTML, HTML labels its fields primarily with a label element. And for those of you who know that, you know, label is actually an interactive element in HTML, right? So it references a field, and then when a screen reader encounters the label, it uses the label content to announce the field. When the label gets focus, it transfers that focus onto the widget. And also when you click on a label, it'll send that click event onto the widget. So if you click on the label of a checkbox, it toggles the checkbox, right? So we have nothing like that in PDF today. So we are proposing a new annotation or new widget type that will mimic this same behavior for PDF. And we'll also make it a widget that's accessible through expressions so that you can change, say, the text of it or the appearance of it as well. There are special cases that are not handled by the common one-to-one correlation between label and widget, right? So in this example, you have table headers where one label addresses and multiple widgets, right? And you have the inverse case where you've got one widget that's referenced by two different labels. And even yet, more different cases. In this case, you got a field with two labels of sort of different categories. You have a primary label and a descriptive label. So for all these, we look to HTML, what they do, and they have area attributes that you add to your HTML markup, and it describes these situations for the screen reader. And so the intent is that we do the same, right? We can attach these attributes, these properties, into our structure tree to convey that same information to the structure readers, to the screen readers. Then on to field grouping. So if you create a group of radio buttons in an HTML document today, any accessibility checker will fail you if you don't put it inside a field set element, right? So it's absolutely mandatory. Radio buttons have to be inside a field set, and the field set must have a legend element. And a legend is, it's kind of like a label for a field set, except it's not interactive. So anyways, field sets, by the way, are a good practice, not just for radio button groups. You can group your address fields in a field set, right? And then your screen reader will announce that now you're entering your home address. So it gives you a little more context when you start seeing being prompted for a street name. So anyways, we're going to leverage this. PDF has always had a hierarchy of fields, right? We allow nested fields in acroforms today. We refer to sort of terminal widgets and non-terminal fields, and so but I think we happy with some terminology. Sounds less like a cancer diagnosis, and maybe talk about these as nested, as field sets rather than as non-terminal widgets. And then we allow for a top-level field set that's kind of special, right? One that aggregates the entire form. And we call that a form root. And that'll also enable us to actually kind of have multiple forms in the same PDF, which will make things like combine operations a lot more predictable and straightforward. And we'll, repurpose the label widget to work as a legend as well. Now onto derivation, and this is probably a little bit outside the scope of our working group because this is probably in the domain of the derivation or reflow group. But the general mappings are, of course, a form root would map to a HTML form element, and a non-terminal field would most of the time map to a field set, but it could also be some other HTML grouping element like a table or a row or a section. Similarly, a label most of the time will translate to a label element, but could also be a field set legend or a table caption or a section header. Field widgets, in the end, will obviously find their way to be some kind of HTML widget. And for the vast majority of properties that don't map into HTML, we would just use data attributes. So look at that in one example here where I've got a purchase order, the top level form root maps to a form. The address field set would map to a field set. And then I've got a legend and a label that map to the corresponding HTML elements. And in our case, in our implementation, we're mapping fields into custom components in HTML, right? We find that's a more, it's a much easier way to deal with the content in a uniform way. And let our JavaScript libraries expand those into the right kinds of widgets. So JSON. So 20 years ago, XML was the gold standard for data exchange, and now we need to move on and do JSON. We will continue to support XML, of course, but we want to be able to do data exchange in JSON. So we'll enhance the submit method so that you have full control over all aspects with the verb, the headers, the body. You can transform the data on the way out and have full access to the response as well. And on data import, we're also going to extend this to carry data that's not necessarily bound to fields. And to that end, we're introducing something called a data model. And if you think about this for a minute, if you have a JSON schema that you want to support, and maybe it's got a couple hundred field values in it, then in traditional acroforms, you would have had to create 200 fields to carry that data forward, right? And so even if your form is only actually editing about a dozen of them, then that seems like overkill. So the idea here is that we have a base data model that can carry all kinds of data, and from that we overlay the field data, right, which in some cases will intersect and overlay the data model, but in some cases will be outside of it. And the result of that, what you see on the right-hand side, is the merged data model, and that's then the data that gets sent to the expression grammar for evaluation for your expressions, for your form logic. As mentioned, we want to be able to support our customers who come to us with JSON schema definitions that they want to support. JSON schema won't appear explicitly in the grammar anywhere, but we are providing all the tools that will allow you to shape your JSON exactly as you need to. So it starts with, having the hierarchy of fields and field sets introduce hierarchy in the data, just as your schema would. Then we've taken on many of the value constraints, validations that come from JSON schema. And then lastly, JSON schema has some relational attributes. You can say, you can express a schema that might have, let's say, an American address versus a Canadian address versus a UK address. And you'll have tools that will enable you to make sure that your data conforms to whichever one is appropriate. So JavaScript is one of the bigger topics here. So I probably could have said this less provocatively, but, and don't get me wrong, I love JavaScript. I'm a JavaScript programmer at core, right? But in the context of PDF, it really is problematic. And now that we are more and more rendering our PDFs inside browsers, this idea of running user-authored JavaScript in a browser is maybe not such a great idea from a security standpoint. And what really irks me is that if you want any kind of interesting logic in your form, you really have to hire a JavaScript programmer. I know a lot of people in this room have probably made money being that programmer, but we really need to allow form authoring to be more accessible. I know, our vendors, we struggle with finding a consistent JavaScript runtime that behaves properly in all the platforms where we want to view PDFs. And at the end of the day, having JavaScript is, well, how should I put this? We give a programming language to our users, and they created programs. We didn't see that coming. But I've been on the receiving end of having to debug a customer form with 20,000 lines of JavaScript in its own custom rules engine, and it's just not what we intended to do, right? And you create these PDFs that don't run consistently in different viewers, and it's just not good for the PDF brand, really, right? So we want to replace JavaScript with an expression grammar of some sort, and our starting point is to model it after what we do in spreadsheets. The idea is that a spreadsheet author, somebody who can come up with formulas in Excel, ought to be able to code logic in their forms. So we want expressions that return values that populate the current field. We don't want looping or variables, but we do need to sort of replace cell addresses, tabular row data with references into the JSON data. And we want these things to be kind of more encapsulated than JavaScript is today, right? In a calculation script in JavaScript today, you can really touch any part of the PDF. But really, we want expressions to only affect the current field. So our starting point was open formula, a nice, publicly available specification for formulas. And then for JSON, we look for a JSON path derivative. And if JSON path is new to you, think about, JSON path does for JSON what XPath did for XML. There are a bunch of open source JSON path derivatives available out there that we looked at. But there's one that kind of dwarfs the others in terms of its adoption. I think it's skewed slightly because it's being bundled with AWS, but nonetheless, JamesPath turned out to be our choice. It's you can go and explore the site. I should point out, JamesPath is not just a grammar for addressing in paths into your JSON. It also allows you to craft expressions that will transform it and morph it from, say, one shape into another. It's quite powerful. It's a well-defined grammar. There are open source implementations available in lots of platforms. So we chose that as our other underlying technology. So we've come up with something we're calling json-formula. It's a mashup of those two grammars. And to get things started, we have an open source implementation of it available in JavaScript that's under development. But if you go there, you can. There's actually on the README page, there's actually a link there where you can go to GitHub pages and actually try it out. Right. Documentation is a little light right now, but it's coming. Tons of functions available for that would look familiar to all of your spreadsheet authors. And just to give you a flavor of what some JSON formula expressions might look like, given the data set on the left, address.street does exactly what you think it would navigate down into the hierarchy and find the value of the street field. And you can use your substitute to do a string replacement. And then you can start addressing arrays of values, right? The asterisk operator allows you to get all the items. And then if you look at their price property, it will return you an array of price values. Then an interesting thing we've done is we've introduced array operators. So in this case, I can multiply one array by the other and get a third array. So it just does an element by element multiplication there. And then I can take the sum of that, multiply it by the tax value, and then round the result. So and if you're, again, the intent is if you're a spreadsheet author, this should look kind of self-evident. In this case, I've taken an expression, I've reformatted a phone number into some kind of expected format. And you'll see below, you'll see in the top expression that address.phone kind of repeats itself throughout the expression. And JamesPath does something cool. It's got a pipe operator so that I can have that expression occur just once and then refer to it with the @ symbol in the subsequent downstream expression. So JSON formula by itself is not forms specific, right? It's just about addressing and manipulating JSON data. And then as we integrate it into forms, the expressions will be configured the same way JavaScript was, as event listeners. And a simple expression that returns a scalar will simply assign the value of the field. And if you want to do something a little more complicated, like assign field properties, then you return a map. And then we use the key value pairs to assign the properties of a field. The intent, again, is that the common operations are easy to code and the difficult operations are possible, right? You can still come up with very complex expressions, but those are for the advanced users. And just to segue a moment away from the actual language itself, we're updating the event processor. So now we can dispatch events, and not only that, but dispatch custom events. And so that's a way that your button can signal other parts of the form that they need to update or take an action, and that's they would just have an agreement on what kind of event that they're going to receive. And I should point out here that if I look at the set of events, especially the set of form events, it's probably smaller than the set of events your average JavaScript programmer would be exposed to today. And that's because we will, in the context of forms, expose only the form events. So you won't have access to other document or app events, right? So the forms kind of gets sandboxed on its own. And so, in the past where you would have written a JavaScript application, if you will, that controlled, your bookmarks and your zoom levels and your menus and forms on top of that, we're saying, no, we're going to sandbox this down. This is just for forms, right? Form events, I think just similar to today, they kind of traverse depth first, which is not, if you're an HTML programmer, you're probably not used to that. But our field events do behave much more like HTML events. So they initiate, they start out a field, they bubble up the hierarchy. You can stop their propagation, you can cancel them. Well, not all of them, of course. The focus and blur, for instance, don't propagate, I think, or don't bubble. You'll notice there's no calculate event. It's been replaced by a change event. But and we've introduced valid and invalid events. Other than that, the set should look kind of familiar. So as we integrate JSON formula into forms, what do? We add some functions that are specific to forms. The previously mentioned way to dispatch events, and then of course the submit, import, export that deal with form data, and format and parse, which is we'll get into is the formatting and parsing functionality that's also unique to forms. And we add a couple of global symbols to make it easier for the user to reference the current field or the root of the forms tree. So when you reference a field, if you just reference it by its name, you get what you would expect, the value of the field. But if you want to dive in a bit deeper, you can look at the property names, and they're prefixed with a dollar symbol, which allows them to be differentiated from children in the hierarchy, right? So field names will not be allowed to start with the dollar. And so we'll look at a couple of expressions here. So obviously, if I have a simple expression that says sum the amounts, and that's all it is, then that's going to assign the value of my field to be that amount. And in context, then you'll see that occurs in the events dictionary under the change event. And a couple more, slightly more complicated. If I want to assign both the value and the color of the field, depending on if it's positive or negative, then I return a map that returns the value and the color. And if you're like me, a little pedantic, and you don't want to repeat that sum expression twice, then you leverage that James Path pipe operator that I was talking about previously. And so let's compare this a bit to JavaScript. So here's my sample case. So I've got a first and last name. I want to concatenate them, turn them to uppercase. So in the first example, I go out and I get field, first and last name, and then I assign the event value to be the uppercase of both of those. And then the JSON formula equivalent is, again, what I hope would be obvious to a spreadsheet author. It just uses the upper functions to concatenate those three things together. And another comparison here for you, if I got a payment area and I can choose cash, check, credit card. If they choose credit card, then I need to make my credit card field editable and required. And so here's how I would do it in JavaScript, and below would be how I would do that using JSON formula. And so hopefully you can see that it is simpler, and it is hopefully something that takes a skill set somewhat less than your average JavaScript programmer. We're asking implementers to consider something we're calling dependency tracking. So anytime you evaluate an expression, you should be able to track, sort of which fields do this expression touch when it evaluated, and those, if you track that, then you know which fields are dependent on which other fields, and so that when a user updates a field, we ought to be able to say, well, I know these three other fields have calculations that use this field value, so I'm going to emit change events to them so that they'll intelligently recalculate themselves. And so to that end, we expect not to have to burden the form author with any kind of a recalculate all or any kind of that kind of logic. So on to constraints. So in this area, we borrowed heavily both from JSON Schema and from HTML5, right? So JSON Schema allows you to say, for instance, my data needs to be an integer or a Boolean or a string and so on. And HTML5 similarly has attributes like that on their input elements. And then, then you can see there's the kind of list of all the ones that we are looking at. A couple of pretty open-ended ones still, a regex expression to validate a field. And the last one, if all else fails, you can still craft a JSON formula expression to return a Boolean to say whether the value is good or not. So again, by way of comparison, in JavaScript, if I had an age field and I wanted to validate that it was an integer and that it was a positive integer, then I'd start with a string value and I parse it and then I check whether it's got a decimal component, and if not, if it fails, then I do the old app alert and set my event return code to false. Whereas in now we have enough expressive constraints that we can do all this without any script at all, right? So we can just say in the constraints dictionary that it's a type integer and that the minimum value is 0. And we can also give it, provide a validation message. So there'll be no more app alert. It'll be just up to, we'll emit an invalid event if it fails, and then it'll be up to the host application to determine how best to convey that validation message onto the end user. One of the things that fell out of this was kind of cool is, we're all used to using radio button groups. So now this allows us to introduce something called a checkbox group, right? And the use case here is I'm ordering pizza toppings. I'm allowed to check up to 3, and after that I can't. It doesn't. We don't want to allow them to check any more, right? And if they want to change their selection, they have to unselect one before they select a new one, right? As soon as they hit 3, all of the unselected ones go to blank, and you want to return the result as a single value. So the way we would declare this is you would have a group of checkboxes, each with the same name, and you can see that the constraints dictionary says that it's going to be a type of array of strings, and that the array has a maximum number of items of 3. And then each checkbox would assert what its enumerated value is, right? And so you put that all together, and then you get that checkbox group behavior I just showed you without again having to write any expressions or anything. So on to Locale/language support. I know I keep calling it Locale. I know the attribute we use in PDF is the lang attribute, but lang will be an inherited property for fields, and it'll allow us to get locale-specific behaviors for fields. So in other words, the date formats you'd expect in your locale, the currency, radix, 1,000 separators, everything like that, as expected for your locale. The work for this is again, based on standard. Unicode has their ICU standard. They also have open source implementations in C and Java. JavaScript, it has its Intel package, which is not API compatible with the other two, but the Intel package was actually largely informed by the ICU standard. So it has a lot of the functionality you need, but not in the same API format as the ICU libraries. We're going to use patterns in formats in 3 different ways. Most of the time, you use it to display the value of a field when it doesn't have focus, right? And then moving on. Oh, I'm getting the card. Yeah. Okay. You probably would like to specify the format when you edit the field. So let's say if it's a date format, you want to, is it going to be month, day, year, day, month, year, whatever. You'll be able to specify that they might have a short date format when they have focus, a long date format when it's out of focus. And again, when you're serializing your data, then you can use a picture to shape your data on its way out. So just some examples for you. If on the left-hand column is some sample values. The next column is a set of skeletons or patterns that we would use, formats. Combine that with language, and then you get your result, right? So we had the first 2 examples are currencies, and they then display as you'd expect for those locales. And then, in terms of date formats, there's shortcuts. So you can say, I think it's short, medium, long, and full for date and time values. Or you can craft a really explicit picture clause yourself. So then on to time zone. So we struggled a bit with this, but in the end, time zone turned out not to be a really difficult implementation, but really quite powerful. So we're going to allow a time zone, an inherited time zone property, and allow users to specify the IANA time zone values. And so the way this works is you can specify in your format that this field holds a date time value, and similar to JavaScript, that gets processed internally as a UTC or GMT value, and then when it interacts with the user, display or input, then it converts it to the local time zone. And in JavaScript, we get that the time zone is inherited from the browser normally, except in our case now, the time zone will be inherited from the field itself. And of course, different fields on your form can have different time zones. So this is a screenshot I've taken from one of my sample forms, and you can see what I have here are 3 fields with the same name. And if you know your Acro forms, you'll know that fields with the same name share the same value. So these are 3 fields with the same value, and in 3 different languages or locales, right, in each case, and in 3 different time zones. And so what you get is, the time values displayed in the time zone and in the language of the user as they would expect in each of those locations. So, extensibility. We're going to allow custom properties because we didn't think of everything and we can't do everything. So we will allow authors to put custom values, and they will be accessible in script or in expressions, right? You can read and write them. It's a great way to do things like squirreling away some translated strings, combo boxes, workflow information, whatever is extra that's needed for your fields. We'll allow for custom widgets, but we'll insist that your widget then also defines sort of a base type. So if you bring it into a viewer that doesn't understand your custom widget, it should have a fallback to something that should work in the broader set of viewers. And then, overall, then the extensibility mechanisms that we have in place, I've covered most of these, right? Extra data, custom field properties, custom events, and widgets, and then, your host application able to respond to custom events. So, in this, I think what you'll find is that there's a lot of leeway for your form authors to really craft the experience that they want. So, just as I get to the red card, here's a summary. So what we should end up with, if all goes well, forms that are easier to author, and a filling experience that's more accessible, works in responsive mode, and internationalized, and is better interoperability in terms of being able to exchange data and extensible. And just maybe that will take us into the next 20 years of forms.